Okay. Our next presenter is Walt Flood IV. He's a fellow of ACI, assistant engineer and project manager at his family's testing and inspection business in Chicago, Illinois. Walt has been involved in testing for much of his life, with the majority of his work within the high-rise market in Chicago. He actively participates in technical and board-level committees at ACI and ASTM, and is a licensed professional engineer in Illinois and Indiana. Walt's going to be talking about if we really want to put super in this.
Thank you very much, Matt. So yeah, I'm Walt. Welcome. Thanks for coming to the session and attending the virtual convention. First, I want to say the nice thing about Vista Tower specifically is Eamon, Jack, and I will probably all speak about it a little bit, being in the same market, but they've changed the name of the tower based on who has controlling ownership so many times, I think 3 at this point, that we could just use a different name and talk about the same project and no one would know any better. So I'll try to call it something other than Wanda Vista. St. Regis, I think it goes by now. But so yes, the title of the presentation is "This Isn't Pumping Well. Do we really need more super?" One of the things Eamon showed was that nomograph, and I think it was broken because he said something about 4 inches. And I don't think I've ever met a pump operator that said anything less than 6 was even pumpable. But the natural tendency seems to be to make it ever wetter. All right, general outline of what I'm going to talk about. First, a little bit of a big picture on just the framework of our market and some of the conditions driving some potential issues. What kind of concrete, the typical concrete, what does that actually mean? It's probably not really typical, at least that I'm talking about. For the rest of the US, I'm going to focus more on the high strength in deck mixes that we're using on most of our high rises here in Chicago. And then some things to be aware of, which is most of the observations and things to watch out for. Couple of recent projects here that are currently ongoing, showing 369 West Grand is one of them. The red purple modernization line here, modernization program here in Chicago, all with pumped concrete. First thing, general overview of how high rises are built, at least in our market. And Eamon alluded to this as well. It's all on a 3-day cycle. So day 1, the second half of the columns on the working deck are placed. Day 2, shear walls go up, the core goes up. And then on the 3rd day, the deck is placed. That same afternoon, half the columns go in and it starts all over. So the moment anything slows down, it's a big problem because it doesn't take a whole lot to mess up that 3-day. In Chicago as well, there's a pretty hard ordinance that's enforced for starting work before 8 a.m. We used to be able to get away with it. There were still some places that didn't have necessarily a whole bunch of people living, but that isn't really the case anymore. So there's usually at least one educated neighbor that's calling it, 7:49 a.m., saying they heard noise on the construction site, and the police show up, and I've seen superintendent get hauled off in a cop car. So they take it seriously. So a couple more photos of that progress, the deck being placed with placing boom, and then also the columns, that first set of columns going up. You can kind of see the deck down there. That deck might be 2 hours old, that they've already got half the shoring up ready for the next deck. Also, some more general overview. So many of our structures now, the vast majority are using post-tension decks. And then when we're servicing a job like that as a testing lab, we usually do have a technician on the pump to monitor the concrete, a separate technician just on 4-day. Because with that schedule, all the rebar is not usually in when it comes time to start placing. They might have the first half ready, but the other is still going in the top load. So that main lead technician that's doing the inspection has to stay up on the deck to monitor the end of that rebar placement, and then also make sure the post tension stays in place. Usually they have to measure floor flatness. So we usually have a separate technician on the pump communicating with the lead technician on the deck to make sure everything's, going well. And got a picture there on the right of a test setup, basically next to the pump, where we've got our cure box and our tiny little home that we're allowed on a project. So this typical concrete that we're working with, most of the deck mixes are between 6,000 and 9,000 that we're working with. The columns and shear walls go up as high as 18 or 20,000. Specified, usually not much over 12, but that depends. Sometimes on the St. Regis project, they were limited to 12,000 specified, but there was a modulus specified. And in order to hit that, you basically had to have 18,000 or 20,000 psi concrete. So while it wasn't specified, that was what was actually being placed. But all of it is really high slump, 8+. Because of that, it's essentially pointless to test it with a traditional slump test, because every test would be the same. 8.5+. What's an 11-inch slump mean? You can't really monitor any quality with that test. So basically, it behaves like SCC. It isn't technically SCC, and because of that, we test it that way. We tested it according to C1611 slump flow, just like SCC, and monitor quality that way. These higher, especially the high strength, the column and shear wall mixes have so little water in them and so much super that they're non-Newtonian. They stick pretty well to the inside of a drum. Like if the drum was stopped and then started back up real quick, it would probably go around once or twice before it started mixing again. So it's pretty dense stuff. If it sits in your wheelbarrow and you try to make cylinders, if you push the shovel or scoop real hard, it's not going to penetrate. You have to go nice and slow and get it that way. So when Eamon's pumping, that's why he needs those 2 trucks at a time, because if you have to stop to wait for the next truck, you might not get that pump started again with those real sticky mixes. So into the things to be aware of. Generally, when we're just placing the columns, just placing the shear walls, it's one mix. You can have one consistency, slump flow on the mix, and it's not too much of a problem. Usually the problems have arisen on that deck placement day when you've got multiple mixes coming in. Really, the critical issue that really appears is because of the puddling at columns. So in a lot of places, if you have columns even as high as 12,000 psi, you can use the same deck mix. You just use a high strength deck mix. You don't have to worry about using a separate mix to puddle. And what I mean about that is 318 allows a difference in deck mix where the columns penetrate the deck by a factor of 1.4. So if the difference is greater than that, then you need a separate mix. Usually you use the same column mix to carry that load through the column, so you don't have basically a weaker layer in between. So that's where some of the issues arise. So one of the things that really happens is with modern concrete batch systems. So in order to puddle near at the column, these mixes are very wet, right? A flow usually in the neighborhood of say 26, 28 inches, something like that. And if you try to put that into one place, 8-inch thick deck to mushroom or puddle for the column, it's going to flow out 20 feet over the deck. So in order to get that to stay in one place and not place your whole deck at 16,000 psi, you need to tighten it up. Well, when you put a lower slump down in the batching systems, usually the only thing it knows to do is to hold water. But if you already have a 0.22 water cement ratio and your sand's wet and you try to hold water, there isn't a whole lot to hold. And it gets even bonier than it was before the mix. So it shows up on site and nobody wants to work with it. So they add super, make it wetter, right? Well, that makes it even stickier and even harder to pump. So that, and hence the title of the presentation, they always want to add more super, which don't blame them. It's not easy to work with, but it doesn't necessarily make it any easier. Also, when there's a whole bunch of super added to the mix, it really starts to get unstable. And you start getting problems to the point of getting segregation, air entrapment issues, things like that. Generally, the contractors are educated enough with these higher end mixes to know that they can add water. But because of that, there's usually 55-gallon drums of super on site that they use liberally. There was one job I was covering where they were placing a parking deck, and it was coming in at an 8, 9, 10-inch slump, just really wet. And they were just adding, the contractor was just adding liters of super to each truck without even looking at the concrete before they even looked. So I was getting pretty frustrated, and I went to where the trucks were staging, 5 trucks down the line to try to get ahead of the labor and test the concrete. And I got out and got a load, and I had been talking to the QC at the plant already to get it a little wetter. They wanted it wetter, and tested it and got, like a 10.5 or something, some nonsense. And so I was pretty happy, and went back to the guy at the pump and said, "Oh yeah, you don't have to dose anymore. I tested it. We're good. It's coming in plenty wet." And he looked at me and kind of shrugged and told the laborer, "Okay, only use half as much now." So now it's only half a liter. So then they kept dosing anyway. But what can you do? At a certain point, it's definitely an education issue with the guys on site, with the pump operators, the producer as well. Here's a picture of the screen on the pump. What we ended up doing is working, projects like St. Regis, where McHugh is involved, and really any of them is working real close with both the contractor and the producer to watch both the pumping pressures as well as that flow, both at the bottom and up on the deck, to help control the mix and get things to work. It really only works if everybody's there working together as a team. What we ended up doing on one of the projects where we were having some issues was to actually put together a separate mix for that puddling. So it wasn't really a separate mix. It was the same mix, but held back some of the mid-range and super in it to make it a little stiffer. And then the contractor knew that they called and ordered this different mix number from dispatch when they needed it on the deck when it was stiffer. And then they kind of avoided those issues with the computer being smarter than us and holding back water and things like that. And we're able to solve it that way. But those types of things can only really work with the team, all working together. And there's some of our cylinders down at the pump, the high slump, after we made them, getting ready to go into to curing. But here's some issues that we've had when the mix does get unstable, when there's too much super. I keep saying super, but high range of some kind usually is what's being used to wet it up. We've seen some problems with additional entrapment of air as the mix destabilizes. So this one on the left, it was non-air entrained, but once the mix starts to destabilize, it's so wet and so much flow that it seems to entrap more air during both discharge and pumping, as well as placement. It's usually high strength enough that it's not enough to cause an issue. You still get good strength, but it's still not the quality that anyone's looking for. The one in the middle, some serious segregation, inch and a half. That's in a 4x8 cylinder slice, is what you're seeing. So there was so much super to the point where the mix no longer could hold itself up. All the coarse aggregate floated to the bottom. Same thing was happening in the pump in that long, 200-meter line. There's no way that as it's going up the building that all your coarse aggregate's staying, in the mix. and that's just increasing the pumping pressures, making it harder. That stuff's pretty angular, and as it settles like that, the pumping became an issue. But same thing in the columns. You get a 10-foot tall column, an inch and a half in the 4x8 cylinder is about 16%. 16% of a 10-foot tall column is over 18 inches. That's not good. We didn't have any trouble with brakes in even the segregated cylinders. We'd still get the crazy high strengths. That was okay, but we knew everybody knew it was a quality issue. The producer worked to remedy it, and as well as education of the pump operators and everybody involved to try to eliminate it. In some real bad situations where the mix really destabilized, there have definitely been times where the contractor ends up needing to chip out a couple of feet of the top of the column and pour it back in with the next column pour. But usually that only needs to happen once before the problem gets solved. And just with these high-end mixes and low water cement ratio, it seems like that knife edge to fall to one side or the other is a little bit narrower. And gradation becomes a little bit of a more important as well, which I'll talk about on another slide here. The last one here on this page is actually from a 10-foot thick mat, and there's a big piece of rebar there, which probably didn't help things, but the contractor added a whole bunch of extra high range in order to increase the flow of the mix so that they didn't have to bother with moving the pesky hose. It was way easier to just wet it up and let it go 50 feet down the line, move it with the vibrators. What could go wrong? So yeah, they had some issues with segregation on that. Same thing, too much super, mix destabilized, and that was it. And here's, I put the Tarantula Curve from Dr. Lay, which was developed for pavement, but some of the same issues with our mixes for pumping. If your gradation changes, you do need a tighter control of your gradation of every aspect of the mix. When you're working at the higher end here, there's a little bit less room for error, and that's something that needs to be watched to maintain pumpability. But ultimately, it takes everybody working together. The batch plant operator needs to know how the computer is going to respond to his different inputs. The plant QC keeping an eye on gradations, and as well as the flow as it leaves the plant. The pump operator has to know not to add too much super. Or we've had issues where you get somebody in that really wants to keep their pump nice and shiny, and you've got a 0.22 water cement ratio, and the guy at the back of the pump spraying the pump down all the time. There ends up being a little bit of water going in that starts to add up and can cause issues. The lab has to be part of the program. I know usually it's good to ignore the lab, or like to ignore the lab, but sometimes it's better to work with them so that everybody's on the same page and it's almost just another part of the team, another set of eyes that can help out. And then also on the deck, obviously, if the finishers, if the placing crew isn't happy with what's coming out on the deck, then it doesn't really do any good what it looks like at the bottom. But yeah, that's about all I had. Definitely, it helps to work up front, establish some slump targets or flow targets down at the bottom of at the base, correlated with what they've got, coming out on top, what they're happy with, and work from there.
Thanks, Walt. There's one question in the Q&A bar. What slump flows do you generally see targeted on the projects you've been on?
Yeah, and it depends a lot on the crew themselves that's placing. A lot of them here really like it pretty wet. So most of the time for column mixes and core mixes, as high as 20, 26, 28. At about 31 was what we established was about the upper limit when things really started to fall apart. If you started to approach 30, 31 inches of spread, it really became an issue.
All right. Thanks, Walt.